Be talking about the commoditization of algorithms today. And, as Neil mentioned, I founded a company that is a two-sided marketplace for algorithms. What I realized was that there are lots and lots of different types of algorithms out there that are performing at high quality that companies can't get. Prior to starting this company, I actually was head of product management at a large financial institution called State Street, where I was building a true AI mobile product. And I frequently ran into situations where I couldn't quite get access to the types of third-party technologies that I needed. So that's kind of what led me to start this company. But I do have a super quick story before we get into the details about why this is happening in the industry today. So a while back, being in tech, a fellow tech entrepreneur, very, very well known in the space, invited me out to his very remote luxury house in Colorado, where he asked me to participate in a little experiment that he was running. Very prominent tech person, and I don't know why he reached out to me, but being both in tech, he did. And it turns out that he was trying to actually conduct a version of the Turing test. So if you're not familiar, this is Alan Turing, Benedict Cumber Turing, who famously had a test that where the idea was you could ask a machine various questions and a human participant various questions. And the idea was that if you couldn't distinguish between the human and the machine, that the machine passed the Turing test. It became indistinguishable from human interaction. So that's what this gentleman invited me out to his Colorado place for. And it turns out that he actually had a big old robot built. This is actual, completely not doctored footage of me interacting with that robot. Kind of amazing. Long story short, it went really poorly. The robot, went on a rampage, locked me in there. I died. And if you're saying, damn, this is the plot of the 2015 movie Ex Machina, I don't know why you would think that that's crazy. This totally happened. In the real world, you may have, if you have any experience in the data science world right now, there is something called GPT-3, which may have passed the Turing test. GPT-3 is a natural language processing engine that has done some pretty remarkable things. And such as, it has written fake blog posts that were so indistinguishable from human text, and not just indistinguishable, kind of popular, that it actually rose to the top of the popular site Hacker News. Another recent, I think that just happened a couple weeks, October 8th, a GPT-3 bot was posting comments on Reddit, and absolutely no one noticed. In fact, many of its comments were upvoted, they were responded to. There was a bit of a controversy because the bot responded with empathy on a post about someone's loved one passing away or someone having a hard time. And it was a computer that responded back with its own fake scenario of a similar situation that happened to it, which got wildly upvoted. So we're seeing some pretty remarkable advances in AI, in data science more broadly. So this is actually really important, because something like this, where it can potentially pass the Turing test, although this isn't a true one-on-one interaction with an individual, has ripple effects throughout the industry. Alan Turing, what do you think of that, and how's the presentation going so far? Alan Turing, stop! Alan Turing loves my presentation. That's So with the advance of things like GPT-3, which used to be, part of an open source community, but has now since been reduced to a license that you'd have to pay for and get access to. But because of advancements in it, what we're seeing is a rising tide raises all ships scenario, where those types of technologies actually tend to trickle down into the industry. So while you might not be able to get access to GPT-3 right now without paying an arm and a leg, the types of platforms that arise to support this type of technology get open sourced and widely available. The types of knowledge that get shared through the teams of data scientists working on it become much more available, and those trickle down to other technologies, which then simultaneously improve as well. And this is having kind of fundamental shifts in the industry, leading to the commoditization of some types of algorithms. But don't just take my word for it. I'm actually amazed, and we are lucky enough to get an expert in the field to record a short video for us explaining this shift. Honestly, I can't believe how we got this guy to do this, but a super expert in the field. So I'm just going to play that short video from him. Thanks for having me, Dan. And that's right. Right now, we are currently in the midst of seeing a shift from data science 1.0 to data science 2.0, where data science 1.0 was primarily controlled by the data scientists who had access to the right coding languages and techniques to build models. And now, in data science 2.0, with the advent of technologies like Docker and Kubernetes, as well as AUTOML, we're seeing business users and engineers being able to access models that they haven't been able to access before, as well as train simple, basic models. We've actually seen this shift in technology many times before. A great example is with the web, where in Web 1.0 in the early 90s and 2000s, it was characterized by the fact that you had to send tickets to your web developer to get any kind of changes made to your website. Then, in Web 2.0, we saw the advent of content management systems, where business users could make simple changes to their website themselves. The same thing is happening right now in Data Science 2.0, where technology has made it accessible to a broader range of audiences. And this is actually going to have profound implications for small to medium-sized businesses that may not be able to get their hands on the type of data science talent that the large organizations can. Back to you, Dan. Wow. Powerful words from an expert in the space. Again, we're lucky to have him, but he's right. We are seeing kind of some big fundamental shifts, and they're stemming from three major trends that I alluded to that come from this kind of rising tide of new technologies. The first one is the availability of the types of platforms that support new data science. I had a conversation with one of gravityAI's advisors. His name's Evan Schnidman. He was the founder and CEO of a natural language processing company called Prattle, which has now, which he sold a few years back. We were talking about how in the early days of Prattle, 5 years ago, he had to build the types of deployment infrastructure to support what he had built from a natural language processing standpoint completely internally. Now, those types of deployment infrastructures are basically available off the shelf. In fact, Airbnb has a deployment infrastructure for AI and data science called Bighead that they built completely internally and now have open sourced. So those are a couple examples of the types of platforms that you might see now that just simply didn't exist that long ago that are supporting freelance data scientists and smaller data science shops in their ability to create these types of technologies. Also, the advent of containers, which is absolutely huge. Containers have broad applications across the web, not just in data science. We saw a talk earlier this week from my friend and colleague Rich Rudzinski and his engineer Todd about containers and their wide application across the web. Well, for us, things like Kubernetes and Docker are actually able to take messy Python code or R code and wrap it in that container. That makes it extremely accessible to business users through a simple, user interface where otherwise, if I didn't know Python or R, I might not be able to access this. Further, because of these containers, engineers without data science experience can actually integrate these algorithms that are containerized into their pipeline without any knowledge of any of the typical data science languages. Again, accelerating their ability to integrate this stuff into their own platforms. And as startups, the access to this type of thing is critical, because you, again, might not have the type of data science talent that really big shops have, especially given the fact that, you know, there's about a 4-to-1 ratio of open recs for data scientists versus the actual number of data scientists that exist. There's a huge shortage, so it makes it very tough. So if you can get your hands on a well-performing model and then be able to integrate it with just basically a junior engineer who knows how to integrate an API, that's huge. We're also seeing things like AutoML. So AutoML is super, super hyped. AutoML is basically auto machine learning. You know, here's an example from Google, but there's lots of different AutoMLs out there. You can actually go to Google's AutoML and try out various versions of it for free. What this does moderately well is allow you to take data sets and train machine learning models all through a simple user interface. So you can see some examples on the right-hand side here. So you can do computer vision. So you might take a data set and be able to train a model through AutoML to recognize you know, certain products if you're a retail company, and automatically designate, you know, let's say you have shoes of different colors, you know, black, gray, and red. You might train a machine learning model to automatically tag them with their color as one example to help you with your inventory management. That's exactly the kind of thing that AutoML does fairly well. It is a little overhyped. It doesn't perform great, but the fact that this kind of thing exists is creating the opportunity for, you know, again, non-data scientists to have access to the types of machine learning models that otherwise they wouldn't have. The next major trend that's affecting the commoditization of models is that there's just an enormous amount of free data out there. Google published 25 million free data sets on the web. And so if you're trying to use something like AutoML that we just talked about, you can actually get your hands on various data sets that include data sets of images, include data sets of you know, various natural language processing, so like articles that you might want to pull in to train a model. And this availability of data makes it extremely easy for both data scientists and now non-data scientists to start training new models. Which is extremely empowering, because previously, you know, you basically just had to have your own proprietary data to be able to do this kind of thing. And lastly, because of the first two trends, we are now seeing widely available high-quality algorithms. You know, there's a number of data science shops and freelance data scientists and PhD students, thousands of them out there, who are creating different algorithms that do various things for verticalized purposes on those public data sets. And all you have to do is do a quick, you know, search for what you're looking for, and you'll find a type of algorithm that will perform relatively well for your business. You want something that does a good job at reading text and classifying? Yeah, that exists. You can go find that pretty easily today. Whereas, you know, not even that long ago, Alchemy, which is a IBM product, you know, you'd have to pay, you know, $10,000 per month or more to have access to. You want something that knows what is in an image and classifies that image? Yeah, you can pretty much train that fairly well off of AutoML to a certain extent. And even if you don't have all the data that you need, again, there's new platforms out there, like one of my friend's companies, RoboFlow, that actually helps you expand your data set, and other algorithms that help you expand your data set. So even with like a limited number of images, you can get pretty darn far with these algorithms. I even have a friend who created something that classifies dreams. They did this project. They took a bunch of dream journal information that was available and created an algorithm that classifies dreams that you can get your hands onto. I don't know why you want it, but it's kind of cool. With the advent of all these high quality algorithms, that are fairly fragmented, that is one of the main reasons why I started this company, gravityAI, right? So you're seeing the rise now of aggregators like us who curate and check these algorithms for security, accuracy, give them really good descriptions, and automatically containerize them so that you can download them. We're not the only marketplace out there. So you can definitely find algorithms in other ones, but we are certainly the best and have one of the most handsome founders. So when you're trying to get access to these now widely available third-party algorithms, there are key considerations that you need to be thinking about as a business owner. Oh man, Thomas Bayes. Thomas Bayes keeps showing up in my presentations. This guy just pops up out of nowhere. Ladies and gentlemen, Thomas Bayes, a famous statistician who created Bayesian models. Yes, Thomas Bayes, algorithms aren't perfect. This is an important consideration. They're not a binary thing, right? So algorithms don't just work or don't work. They work up to a certain percentage. So we do need to look at the various factors and understand how we're going to use those to increase the probability of success. I get your joke there. You worked on probability. That's great. You're very clever. So yes, algorithms are not 100% accurate. It's actually fairly simple to get some models up to like an 80% accuracy or 75% accuracy, but the time it takes and effort to get something from, say, 80 to 85% accuracy is exponential, and then 80 to 87, 85 to 87% accuracy even tougher. So we have to understand the context with which we're using that model and understand that they're just not going to be perfect. But that's actually not that bad, right? Welcome, John Tukey, who's another famous mathematician, who I'm more happy to see than Thomas Bayes, who just keeps popping out of nowhere. John Tukey famously coined the term the bit. Yes, if we can get an approximate answer to the problem that we're trying to solve, we can do a pretty good job with that. So what types of things do we need to know about models that aren't necessarily 100% accurate? Well, there's lots of different ways that we can handle that. One, most models that you think about should have a human in the loop. So let's talk through quickly an example. If you are using an algorithm that detects text out of images, you're likely going to find something that, probably works 80 to 90% of the time. But you should always have a confidence interval associated with that someone can check if the algorithm determines that it's not entirely sure that it made the right decision. Human-in-the-loop models are very common, where you are basically augmenting someone's ability to work through an algorithm. JP Morgan famously used OCR, optical character recognition, that recognizes text out of images to save something like 360,000 man-hours a year in just manual entering of data through, faxed-in forms that they had to deal with. So I highly encourage understanding the consequences of whether or not that algorithm fails, and including something like a human in the loop that will review the results of that algorithm. Another thing that's really important to consider is that, algorithms are just a tool that are part of a larger offering, and design has to be strongly considered when dealing with algorithms. And a lot of the missteps that algorithms have can be handled through good design. Let's take, for example, I own and drive a Tesla Model 3. And I frequently use the self-driving on the highway. Now, the consequences of that model failing while it's self-driving on the highway are pretty darn high, right? So, they've done a really good job training that up. But it does happen. Sometimes one of the cameras doesn't quite detect something that it was expecting. And through good design, the car screams at me to grab the wheel. And you know what I do? I grab the wheel. And you know what? There's very little consequences. So if you can handle errors or situations where the algorithm doesn't necessarily have a perfect track record, through good design, it doesn't matter if you have an algorithm that's 100% accurate. And finally, you know what? Maybe it's just okay if it doesn't work all the time and the consequences are fairly limited. If you've ever perused YouTube searching for Scottish person asks Alexa a question, you will know that they're infinitely frustrated because of the Scottish accent. You know, it's not necessarily picked up through the speech recognition, but the consequences are fairly low. So it just doesn't necessarily matter that much. So it's okay when it doesn't work perfectly every single time. So understanding your consequences and understanding how to deal with those when the algorithm doesn't work is totally okay. Again, this is very important because the widely available algorithms today probably only work up to a certain extent. So with that, we're going to do some rapid fire use cases that you can get your hands on today. And this will be the last thing before we jump into questions that maybe your business might be able to use. So let's say you are a fintech company and you get frequently faxed in or email PDFs of purchase orders or invoices. Yes, that's totally something that is widely available today. So again, this is called OCR, optical character recognition, and you can get very high-performing OCR models on lots of different types of forms. GravityAI, we've got things like W9s and 1099s that you can automatically extract text from. Purchase orders as well. Checks has been around forever. Anytime you use your mobile phone to deposit a check, it extracts the text from that. That's very common and performs very well. Let's say you're a retail company or basically any company that is doing regular marketing and content marketing to an audience. Can you automatically use algorithms today to segment that audience for personalization? Yes, definitely. These are also widely available types of models that previously weren't available to large numbers of people. So if this is basically applicable to any small business that is using something like a CRM to target and send out regular content to. Automating customer service is a really big thing. Yes, you can have clear automated decision trees from models that help get people faster to the types of issues that they're having. And or, there's even models that do sentiment analysis while someone's chatting with a bot or chatting with you on your phone that can detect whether or not an angry Karen is going to need a manager before she even knows she needs a manager, right? And it just straight directs her to one to save that poor associate. Widely available today. Detect customer risk profiles. Again, if you are working in insurance, if you're working in finance, if you're working in anything that does loans, can you automatically detect customer risk profiles for perhaps defaulting on loans or applying for a mortgage? Yes, widely available today. And there's actually pretty well-performing models that you can get off the shelf to get you started. Ask natural language questions of data. And text, for that matter. Yes, we've got a model on Gravity that you can do just this. If you get an invoice that you used OCR on, you can ask it questions like, what was the total on that invoice? And it will respond back pretty darn well. You can also ask questions like, who was the sender? What was their address? And you can do this all at scale. And the applications for being able to ask questions like this at scale through AI is pretty enormous. This is the type of thing that we saw with GPT-3. Detect handguns in live video. Yep. Let's say you're a security company and you've got a video monitoring and you want to detect handguns that someone might be carrying on their person, on their side, in their hand. A company called Cividia that does all sorts of really cool object detection has an algorithm that can detect things like handguns in live video. These are things that are widely available and able to be integrated. Super cool. Optimize routes for shipping. Did you want to start Uber? You can do that. You can start Uber by just having this, route optimization software running in the background to, direct your own drivers. Or if you're, a shipping company, you can optimize routes to get the shipping routes down to their lowest amounts of time. Detect customer churn. Definitely widely available today, applicable to just about anyone who has customers. Predict the likelihood that a patient is septic. Well, this is something that algorithms are doing today, but you probably can't actually have access to that because that's got super proprietary data in it. So who knows? Maybe one day this will be more open source and widely available, but this is something that you probably have to pay for today at scale and uses straight customer data. So that's a few rapid fire types of use cases that you might be able to use today. And one of the things that we're doing with gravityAI is working with companies to help match them what their business problem is and what they're working on with the types of algorithms that are available today, and help them understand through design and human-in-the-loop processes how to implement those. So you're more than welcome to ask me questions about that. Shoot me a text or an email, and I will get back to you. That's my presentation today. Does anyone have any questions?
Thank you, Daniel. Amazingly fun, engaging presentation. Make sure everyone, you give them a round of applause and the emojis. Everyone, feel free to ask them directly in the chat, or you can request the mic. So if you look in the bottom, you should have an opportunity to say, hey, I'd like to ask a question live, and we'll bring you up on screen. So either way, however you'd like, but it looks like you're starting to get some questions. One from Valerie. How does a developer discover what algorithms are widely available?
That's one of the main issues right now that's plaguing the space of data science. There just isn't a good understanding of all the possible use cases that exist. But the short answer is that if you have a vertical problem, by vertical I mean a very specific ask, and there's widely available public data, then chances are that there is an algorithm that either exists today or could be made fairly quickly to address that. Other discovery methods, there's just a wide variety of resources out there to help people find different models. TowardsDataScience.com, which is a Medium property, people are regularly posting about what they've created. Kaggle, which is a very, very popular data science competition site, frequently posts competitions about the different types of use cases that are out there, and winners build interesting models. Reddit has a massive data science community that frequently talks about their use cases that they have. And obviously, companies like mine, which are in the process of aggregating different models on the platform. If anyone's interested, we are not completed with it yet, but we are building up a repository of companies' reviews and the types of algorithms that they've created. If you want to shoot me an email, I can add you to the waiting list as soon as we've done that. We've already got about 100 companies that we've documented the types of things that they've created that are well performing, as well as reviews. And I'm happy to shoot me an email. Happy to share that list with you guys when I'm done with that. Other questions?
I'll read another one for you. We got one from Terry Wozniak. Thanks, Terry. Is there a course on Coursera or equivalent that would provide a good overview of the current state of the art of data science?
The short answer is yes. I have not spent a whole lot of time on Coursera recently. I'm actually a distinguished faculty member with General Assembly, and I teach enterprises about, enterprise level product management and data science. And so I'm very aware that there's an enormous amount of material being created. And if you're looking for just an overview, you're going to definitely find, courses on Coursera like, I would try searching for like data science for execs, which is going to give you a very good overview of the types of use cases or the way to think about business problems as it relates back to data science. Because oftentimes, there's something that, with execs we call shiny object syndrome, where, they're like, we need to throw some AI at it and some blockchain. And, sometimes that's not needed. But there's some good guidelines that you can use to understand what types of problems are right for machine learning or data science more broadly. I've given a talk on this very thing as well. If you just search some of my videos, you'll find various videos on build versus buy decisions when it comes to data science and how to think about that, around monetization of them, how to think about from a product manager's perspective, incorporating data science. But yeah, there's an enormous amount of resources out there. Great question. Thank you. And I got to plug my own videos.
Another one for you from Veronica Furman. Do you have a subscription fee on your platform or other price model for algorithms? So we'll let you plug your platform a little bit more too.
Oh my. Yes. So the way that we work is based off of a credit-based system. So one of the things that is important in data science is the ability to test what you're trying before you actually go ahead and buy it. So we've made it possible to do that through two ways. One, some of the algorithms you can test directly in the platform itself without actually purchasing them. You can upload a sample set of data that you have approved that is not proprietary to you, that you're okay uploading into our cloud, a small set, and you can test it there. And because of our credit-based system, we allow you to pay for a number of credits per month, and then you have access to any number of algorithms on the platform up to that credit limit. So if you have 5 credits per month, you have access to, say, 5 1-credit algorithms, which are simpler algorithms. And then if you cancel subscription to one of those algorithms, you get that credit back in, and you can test and try out various algorithms on the platform. Currently, we've priced them at 3 different tier levels, which you can check out on our website. But we're in the midst of running some additional, since we're still a fairly young marketplace, individual trials. So we only came out of private beta back in July. And while we do have a number of customers using the platform at full price, we're still offering some discounts. So feel free to talk to me or shoot me an email if you're interested in that. One of our largest customers is actually one of the largest healthcare organizations in the world using the platform. So more than happy to talk about how we structure something for you guys. It's the privilege of being the founder and being a young company.
Love that. Thank you. Another question from Doug. Would you mind speaking more about how you've seen data science used in product management or product launching?
Yeah, definitely. So I'm a product manager by training, and I view the world through the lens of desirability, feasibility, and viability, right? So desirability, do people want what it is that I'm trying to build? Feasibility, is it possible to deliver with the skills that I have or the tech that exists today, what I'm, the concept or business idea that's being proposed? And viability, is there a sustainable business model, or is it value creation that's associated with it? And when I think about how data science works in the context of product management, when thinking about, how to incorporate it, I think about it very differently than a data scientist would, because I can recognize that, like I talked about, sometimes an algorithm doesn't have to be perfect. And it's important to know that it's it's much simpler to get a proof of concept of an algorithm that works maybe 80%, right? So when I was at State Street Corporation, we built a true AI mobile product that used natural language processing to read financial news, extract what that financial news was about, both the people, places, and things that are in it, which is called NER, name entity recognition, as well as classify that particular bit of news. Then we used a series of other algorithms to connect that intelligently back to portfolio holdings. And then raise contextualized analytics about someone's investments that they have in their portfolio. Now, I know as a product manager that NLP isn't perfect, so it's not necessarily going to have a 100% success rate in classifying the news. So one, I need to understand from a desirability standpoint what level of accuracy as a product manager is okay for my user. That's probably not necessarily something a data scientist is going to be thinking through. Also, as I mentioned before, how do I handle it when it doesn't perform as expected, error handling, or when it's outside of that confidence interval? Do we have a human in the loop? So we did a number of things at State Street to address these types of things. Other things that you have to consider as, when you're integrating data science into a product is stuff like transparency or explainability, as it's called. The people who used our product wanted to know how we determined the contextualized analytics and ranked the news for them that was important. We ultimately built a feature around that called score transparency. So incorporating data science from a product manager's mindset is really just good product management and understanding your user and doing user testing. Data science is just algorithms are just a tool to help you get what your user wants. Sometimes faster at lower cost or at a scale in data that we just might not be able to do. But if you always take it from a user perspective, you can't go wrong.